Hello my dear students, once again welcome to your online class, and in today's class we will be studying about hydrogen chloride. Okay, so this comes under the topic the study of compounds. So now the last remaining chapters of your chemistry syllabus is the 4 chapters. Starting from chapter 8 to chapter 11 we have the study of 4 different kinds of compound, and the chapter 8 is hydrogen chloride. Then we have ammonia, then we will be studying about the nitric acid, and finally we will be learning about the sulfuric acid. So in today's class we will be learning the first chapter of the study of compound, that is the hydrogen chloride. We will also be learning in this chapter how the hydrochloric acid is prepared from this hydrogen chloride gas. So to begin with the first topic, the preparation of HCl using a sodium chloride crystal. So the reaction is very simple, I have written here as well. So when the mixture of sodium chloride and a sulfuric acid, provided this sulfuric acid must be a concentrated sulfuric acid. So when they are heated below 200 degrees centigrade, we get a sodium. So this compound's name is a sodium hydrogen sulfate. Okay, so we get a sodium hydrogen sulfate and a HCl gas. Okay, the downward arrow shows that it is heavier than the air. So it's very simple to produce the HCl gas in a laboratory as well. So the method followed is same as that we have learned just now. So in the lab preparation of HCl, what is done? The two reactant taken are the sodium chloride, the crystal of sodium chloride, and a concentrated sulfuric acid. And then what is done? And the mixture of these both are heated below 200 degrees centigrade. So we will be learning why it must be heated below 200 degrees centigrade as well. So what is done? In a round bottom flask, a crystal of sodium chloride is taken. So it is the sodium chloride, and through the funnel drop by drop, what is poured? The sulfuric acid, H2SO4 is poured here. So as soon as the sulfuric acid, it reacts with the sodium chloride, as a result of which the moist HCl gas is evolved. So this moist HCl gas through the delivery tube is passed into another vessel that contains a suitable drying agent like a sulfuric acid. Okay, so here we have a sulfuric acid again, concentrated sulfuric acid acts as a drying agent, and then finally we obtain a dry HCl gas, which can be collected by the upward displacement of an air. Okay, so here finally what we get? We get a dry HCl. So the reaction taking place in the laboratory preparation of HCl is, so when a sodium chloride reacts with a sulfuric acid, okay, at a temperature below 200 degrees centigrade, it produces a sodium hydrogen sulfate plus the HCl gas. Okay, so and this HCl can be collected by the downward displacement of an air. So now the question comes, why to heat the reactant below 200 degree centigrade? So if you heat this reaction above 200 degree centigrade, instead of producing a sodium hydrogen sulfate, a sodium sulfate will be produced, Na2SO4, and this compound is sticky in nature. So as a result, it will stick to this glass vessel and then it will destroy the vessel. So there is another disadvantage of heating it above 200 degrees centigrade, will be the wastage of fuel as well. So there are basically the two disadvantages of heating this reactant above 200 degrees centigrade. It's because the first one, if you heat it above 200 degrees centigrade, instead of sodium hydrogen sulfate, a sodium sulfate is produced which sticks to the glass, and the second one, there is a wastage of a fuel as well, because to heat the reactants at a higher temperature, the more amount of fuel will be utilized. So now next comes the test for a HCl gas, and also how to know that this vessel is filled with the HCl gas. So what happens? As soon as you see as soon as this jar is filled with the HCl gas, you will be seeing a white fume, okay, coming out from the brim of a vessel in which you are collecting a HCl gas. So once you see the fume, you must be sure that the vessel is now full of HCl gas. So now coming to the density of a HCl gas. So the HCl gas, the density of a HCl is much more higher than that of the air. So that's why it can easily be collected by the downward displacement of air. The fourth topic, now coming to the solubility of HCl. The HCl is soluble in water in all the proportion. Basically, the solubility of HCl is around 442 volumes. So it is 452 volumes. So that means the 1 volume of water can dissolve 452 volumes of HCl gas. So this also can be simply demonstrated with the help of a simple experiment, and this experiment also proves that the HCl gas, when treated with the water, it's acidic in nature. So what you need to do, you need to take another round bottom flask, okay, inverted round bottom flask, fit it with a cork, okay, and then there must be a 2 hole, so one fitted with a fountain arrangement. So there I have a long tube where at the peak we have a fountain arrangement, and then this is dipped into the solution containing a blue litmus solution. Okay, so this is a blue litmus, and then through other hole we insert a dropper that contains water, and then before this arrangement this jar is filled with the HCl gas. So now as soon as you press this, squeeze the dropper, a few drops of water comes out of the another end of the dropper. So these few drops of water, it is capable of absorbing all of the HCl present in this round bottom flask, as a result of which the pressure inside this round bottom flask decreases and the blue litmus, it ascends upward in the tube, and when it enters into the round bottom flask, this blue litmus will appear as a red or pink also. Okay, so we call this a fountain experiment. So the fountain experiment, basically it demonstrates two characters of the HCl gas. The first one, it is highly soluble in water, and the second one, this HCl gas is also acidic in nature. Now coming to the next topic, the preparation of hydrochloric acid. So the hydrochloric acid is basically produced by dissolving a HCl gas in a water. Since we have already studied that the HCl gas is highly soluble in water in the ratio of 1:452. So when the HCl gas, it dissolves in water, it produces a hydrochloric acid. But the HCl gas is not directly bubbled through the water. So instead a funnel arrangement is made. So in which, in a beaker we take a water. Okay, so this beaker contains a water, and then we have an inverted funnel just touching the surface of the water, through which the HCl gas is pushed downward. So this contains a HCl gas. So when this inverted funnel is filled with the HCl gas, the water being highly soluble in HCl, or the HCl gas being highly soluble in water, what happens? The water gets sucked up. Okay, so in this funnel, so creating a thin air gap between the surface of the funnel and the water, so which creates the pressure difference, and due to the weight of the water itself, the water which is being absorbed by the HCl gas, it falls down into the beaker again, and then next what happens, again a fresh water enters into the funnel, and then again the air gap is created, and then due to the pressure difference, the water which is being absorbed by the HCl gas, it falls down, and this process goes on and on until this gets saturated. Okay, so when the water gets highly saturated with the HCl gas, then a hydrochloric acid is formed in the beaker. So this funnel arrangement, so it does two things. So one, it prevents the backward suction of the water into the tank that contains the HCl gas, and the second, it also provides a larger surface area for the water to get absorbed by the HCl gas. This is how a hydrochloric acid is produced in the lab by the help of the funnel arrangement. So now coming to the next topic, the reaction with ammonia. When a HCl gas or a hydrochloric acid is treated with ammonia, it gives a white dense fume of ammonium chloride, and the reaction goes when ammonia is treated with a HCl. Okay, so what does it give? It gives NH4Cl, which is a white dense fume. Okay, So this can also be regarded as a test of a hydrogen chloride gas or a hydrochloric acid. So what you can do, when a glass rod dipped in ammonium solution is brought to a HCl. So what is observed? A white dense fume is observed. Thus you can conclude that the jar contains either a hydrochloric acid or a hydrogen chloride gas. Now coming to the last topic, the reaction of a HCl gas with a metallic oxide, the metallic hydroxide and the carbonates. So there is a specific formula for you to remember, okay, so which I will write here in the board. So here in the board I have written the reaction of hydrochloric acid with the metals, with the metallic oxide and the metallic hydroxide and with the carbonates. So as you can see in the first part, so it tells us that whenever a metal treated with a hydrochloric acid, it always gives a metallic chloride and a hydrogen gas. For example, when a calcium is treated with a hydrochloric acid, it gives a calcium chloride and a hydrogen gas. Now coming to the next topic, with the metallic oxide and the metallic hydroxide. So the HCl or the hydrochloric acid, whenever treated with a metallic oxide and a metallic hydroxide, it always gives the metallic chloride and a water. Okay. So like for example, the magnesium oxide, it gives a magnesium chloride and a water, and a sodium hydroxide when treated with a hydrochloric acid, it gives a sodium chloride and a water. Now finally coming to the carbonates, when the hydrochloric acid is treated with the carbonates, it gives a metallic or a metal chloride plus water and the carbon dioxide gas. So here the sodium carbonate when treated with the hydrochloric acid, it gives a sodium chloride, water and finally the carbon dioxide gas. So you need to remember, with the metal it gives a hydrogen, with the metallic oxide and a hydroxide it gives a water, and with the carbonate it gives a carbon dioxide. So there are many more examples in a book. So you need to learn each one of them and also learn the uses of hydrogen gas as well. So this is the end of the chapter, the study of the compound hydrogen chloride gas plus the hydrochloric acid. Thank you.